In Algebra 1, section 6.6, we're dealing with absolute value. Now, in the absolute value, we're having to do is, there's certain things in life that are always positive. For example, my distance is always positive. If I'm going to go run for 2 miles and then I run backwards 3 miles, it doesn't mean that I've traveled a total of -1 miles. It means that I've traveled a total of 4 miles. Okay? I'm sorry. 2, 3, 5 miles. So, same thing with weight. You will never be -2, -20 pounds. Your weight will always be something. Okay? So the absolute value is used to represent those distances that are always, those measurements that are always positive. Okay? And these big lines here indicate that it's absolute value. What that means is everything on the inside is positive. Okay? Doesn't mean that it can't be negative in here. In here it can be negative, but to the outside world it'll be positive. For example, if I put this all together and the answer here is -2, in this absolute value world it can be negative. But once I translate it to the outside, it's going to be positive. Yes? So if I traveled a certain distance, it's going to look -1, but no matter what, I've traveled a certain distance. Okay? So the absolute value positive on the inside means that I have ax plus b equals c, or ax plus b equals -c. So that means I can either have a positive number on the inside or a negative number. For example, okay, this might be a little confusing, but just pay attention for 2 seconds, and I put actual numbers. So here it is. The example. The absolute value of x, okay, if I have the absolute value of x equals 6, that means in here, in order for the answer to be 6, I can either have 6 as a positive or 6 as a negative. Okay? So that means if I took away the absolute value, this whole thing, if I took away this absolute value, that means the inside can either equal a positive c or the inside can equal a -c, but no matter what, the answer will always be a positive c, but I have to include all the possibilities. So my x here can either be a positive 6, I'll still get 6, or it could be a -6 and I'll still get 6 as the answer. That absolute value makes sure that I get only a positive number out. For example, if I have x plus 3, okay, if I get rid of the absolute value, so I'm getting rid of them, that means that the original equation can either be x plus 3 equals 5, or it could be x plus 3 equals -5. Alright? So when I want to solve an absolute value, I have to get rid of the absolute value and use the 2 possibilities it could have and solve them. Does that make sense? I have to include all of the possibilities. Even though the answer is going to be positive, it represents more than one answer, or it could represent more than one answer. And if this is a little confusing, I have some example problems. So go ahead and write this down. And I will do some examples. So one more time, and this is very important because it happens common, the absolute value needs to be taken out before you're able to solve it. You cannot solve an equation with an absolute value there. Okay? So if I have an absolute value here, okay, that means I'm going to get rid of the absolute value, but if I get rid of the absolute value, that means my x can either be 3 or my x can be a -3. Does that make sense? And here are my answers. Okay? In here, it says the absolute value is, the absolute value of x equals -1. Well, when I've solved, the absolute value of something cannot equal a -1. Cannot be an equal sign. Now, if I had -1 minus x or something like, and something else except just a number, I might be able to solve it further. But if it's just absolute value of x equals -1, that's never going to happen. Because if I put a 1 in here, it'll be a positive 1. If I put a -1, it'll still be a positive 1. So nowhere will I get a -1. This means that this is no solution. Okay? Because it will never equal a -1. Alright, so here is an absolute value with an equation in. And again, I want to get rid of the equation, okay? But the only way I'll get rid of the equation is if I represent all the possible answers. I mean, not equation, I want to get rid of the absolute value. So in order for me to get rid of this absolute value, I have to represent both equations that are possible. So I either can have x minus 4 equals 8, or I can have x minus 4 equals negative 8. Now, I know what you're thinking, okay? It might be a little bit confusing because you said, wait, it can't equal a negative 8. But this can equal negative 8 when I get rid of the absolute value, okay? This is even with the absolute value, I can't do that. So this one, I'm getting rid of I'm getting rid of the absolute value. The absolute value is no longer there. And in order for me to do that, you know, just like when I'm trying to solve a problem, there's rules. So in order for me to get rid of the absolute value, I must represent the two equations that's possible. So either the inside can be an 8 and I'll get an 8, or the inside can total a negative 8, right, and I'll still get an 8 as the answer. Okay, so please remember that these 8s don't represent what's on the outside. These 8s represent what's the possibility on the inside. Alright, so let's solve. I know this is confusing, just remember this rule. I'm solving an absolute value. I want to get rid of the absolute value signs because I can't solve it with the signs there. So I'm going to take the inside and I'm going to represent it by the two possible answers that can be on the inside and still equal 8. So I'm going to add 4 to both sides. I end up with x equals 12. And then I'm going to add 4 on both sides, but because negative 8 plus 4, I get x equals negative 4. And these are my two answers. Now, the last one is a little tricky because you see, in order for me to do this, absolute value has to stand alone. Okay, it must stand alone. So if it's not standing alone, this has a 4 in it, okay? It's not standing alone. So in order for me to do this rule right here, I have to get rid of that 4. Well, how do I usually get rid of 4? I do the opposite. If this is adding by 4, I'm going to subtract both sides by 4. I end up with the absolute value of 2x plus 3 equals 9 minus 4, which is 5. Now, this problem is very similar to this problem. I'm going to get rid of the absolute value by simply doing what? I'm going to represent, even though the answer outside is 5, on the inside, 2x plus 3 can equal 5, right? Because if 5 is in here, then my answer will still be 5. But 2x plus 3 can also equal negative 5, right? If negative 5 is in here, my answer will still be 5. So from there, once this is set up like you did here, you just solve it. So if this is still confusing to you, make sure you come to me and we'll go over it together. But once you have these two problems set up, then you just solve both ones separately, and both answers are your answers. So I'm going to subtract this by 3. I end up with 2x equals 2, right? Divide by 2. This cancels out, and I end up with x equals 1. This one I'm going to subtract by 3, but what happened here is I end up with a negative 8. I'm going to divide both sides by 2. This cancels out. I end up with x equals negative 4. And that's my answer. Alright? So go ahead and write that down. Try page 356, number 6 and 8, 356, number 6 and 8, and I will see you later.